All right. What kind of problem is this? Let's just kind of zoom out and do like big picture category for this. So what kind of situation are we dealing with? I want category. Like we've done, this is our technically fourth unit. So are we like unit 1, 2, 4, or 6? And what kind of category or title would you give the problem? Yeah, say it. Yeah, exterior angles. But we should say polygon, exterior angles. Yeah, it's having trouble. I don't know if there's something up with the Wi-Fi. It seems to be really bad today. So polygon exterior angles. Why am I asking you to identify the topic?
Proofs.
What was it?
We're doing proofs.
Proofs? Okay. I suppose that could be helpful for proofs, yes. It's because, pretty soon, actually already, we have a lot of information that we've learned. And so if you can categorize, narrow it down to a specific subject, it helps you think through it better. And it helps you identify where in your notes you should look too, right? So like if this was a month ago, that's different than if it was last week, which it is. It's last week's work. So polygon exterior angle sums. It says A, F, and E are all congruent. So A, F, and E are the same. And then it says B is twice A. So maybe call that 2A just to get something into the picture. It says C and D both equal A plus 20. Get that into the picture. And as soon as you do that, it kind of forces you to identify the variable that you're using, which is what? At least hopefully. It's A, because now 3 of the angles are in terms of A. That's how we say it in math. So you might as well go just call these A as well. And now we have at least a variable in every angle that we are working with. What kind of relationship do we use for solving for A? No, we just wrote the word exterior on here, right?
Did I say interior?
You did, yeah.
Oh, I meant exterior.
Okay, but it's not each because is it a regular polygon?
That's right.
Okay. That has to be a regular polygon to use that each formula. So which one are we using? Gosh, if only we had it written down somewhere. That would be so cool. It is too. It's right here. Okay. Total exterior is always 360. So that's the one that we're looking at for this. Sum of the exterior, or you could say exterior sum. Total, I don't care which one you use, but that's the one we're using. Okay, so we know it's 360 on the right. On the left, we just add the angles up. 1, 2, 3, so that's 6 angles. A plus A plus A plus 2 of the A plus 20s, and then a 2A. And now it's just an easy little solve. So we get 3A, 5A, 7A, and 40 equals 360. 7a equals 320. And a 320 divided by 7 is 45.7. Okay, and then it wants us to solve for the measure of angle F, which is congruent to angle A, so 45.7 degrees. Good? Anybody get that? Raise your hand if you did. All right, distance and slope. What's the distance formula?
Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared.
Yeah. I'm gonna move this down, otherwise it's gonna print weird. What do you have to be careful of on distant stuff? Yeah, don't put negatives after you square, that kind of stuff, right? You should never have a negative distance, that kind of thing. Sometimes it's helpful to go label these like x1, y1, x2, y2, so that you can just dump them in your formula where they go. So we'll go negative 3 minus 2 squared and negative 1 minus 5 squared. What's negative 3 minus 2? Negative 5. And negative 1 minus 5? Negative 6. What is negative 5 squared? But if you plug that in your calculator without the parentheses, it will say negative 25. And that's why it's good to know things and not always depend on technology. What's negative 6 squared? It's 36. No negatives right there. And then what is this when we add them together? Square root of 61 is fine for an answer. We don't have to simplify. Well, we can't simplify that, but we also don't need to make it a decimal. All right, slope. The reason I had you try to review slope is you're going to use it a ton in this unit here coming up pretty soon. So how do we find slope between 2 points? Remember the letter for that is m, like y equals mx plus b, so m. But how do we find slope?
y2 minus y1 divided by x2 minus x1.
Okay, good. So I want to tell you something that's nice about this unit and specifically how we use these two. A lot of your proofs will involve both distance and slope. Do you notice a shortcut that you can do if you've done one or the other first? Yeah, I mean, didn't we do the two things right here already? So in going back, we have x2 minus x1, y2 minus y1 in the distance formula. So we don't need to go rewrite the whole thing. We can just come in and say, hey, the y's difference was negative 6, the x difference was negative 5. And we're done. Because in these proofs, you might do 4 distance formulas and 2 slopes. And they may be the same points, but they may not. You might do all slopes or all distance formulas. It just depends. But often when you do a mixture, feel free to copy what you already know into the other formula. If we had done slope first, I would just copy negative 6, negative 5 right here. I wouldn't write all this stuff. I would just go start right here. And it saves a lot of work. Because 6 distance formulas takes a lot of room and it takes a lot of time. And I'm not exaggerating, you will do that. 6 slopes takes a lot of time. So any way that we can make this more efficient is super nice. How'd you do on that? Anybody get 6/5? Okay. Obviously, I had you review that because it's coming up. let's do your homework check. Go ahead and pull those out. So you did odds and then those two systems problems. Number 13 asked for x. Well, it actually asked for BC, but you had to get x first. So x was 8, BC was 4 on 13. And then number 15, angle B is 120. X in that case was 160. Any questions on those? How many of you got both of those correct? Okay. Number 19, y is 15. And then number 19 something, I don't know what this is. X is 21. And y was weird, it was negative 16.5. But that did turn out to be correct. So 21, negative 16.5 on that system. And then the one on the right, x is 7, y is 2. I used substitution on that one. Not that you had to, but that's how I chose to do it. You guys remember substitution? So basically get a variable by itself and then take that expression into the other equation where that variable was. So I don't know if that's the best way to do it. Did anybody do elimination on that? You did? Okay, anybody else? Elimination is the method that's over here on the left. I usually like elimination a lot more, but it's good to use both. Okay, raise your hand if you got x is 7 and y is 2 on that far right one. Just one of you. How about on the first one, 21 and negative 16.5? Okay. 65, x is 43.5. That was a same side interior kind of problem. Number 9, it says these directions are kind of interesting. Find x and y so that each quadrilateral is a parallelogram. Basically, the way you do that is assume that it is and solve for x, and then it forces it to be. It's kind of a weird way to word it. But anyway, this time you didn't need systems. You just set equal going across the page, like across the figure, and then solve to get y19 and x24. Number 11, all those answers were 42. What are we using there? Yeah, say it. Alternate interior angles. We talked about that yesterday being a thing you might use. Okay, number 13. Should have got 56 for angle CDF. And again, alternate interior angles to copy the 34. And then just use the triangle angle sum for 56. So overall, fist to 5 on parallelograms. This is basically all the solving except for proofs. So hold those up. All right, I'm seeing an average of probably over 4 or around 4. So that's good. Any questions on them before we move on to the special parallelograms? There's a lot of stuff with these, so if you do come up with a question, please ask it quickly. You don't want it to snowball, is what I mean. All right, let me scroll through all this stuff to special parallelograms. Name a special parallelogram. What was it? Rectangle, yeah. Rhombus and square, okay? So each of those have all the properties of parallelograms and then a couple more as well. So there's our specials, rectangle, rhombus, and square. It's interesting. What do you usually what do you sometimes call a rhombus when you're young? Yeah, so people call that a diamond shape, but it has its own definition, of course. Let's just go actually to the
Wait,
reference, this one.
is a diamond or rhombus different, or is it just a different name for it?
There isn't really a name, geometry named diamond.
Oh,
Yeah. It's always a rhombus, but so I don't know where diamond came along in the naming, but it's not an official name in math. Okay. Let's see. How can I write this so it's clear? So these have all properties of, I'm going to abbreviate parallelograms, just p-gram, so p grams. In other words, a rectangle, even though we haven't even written anything about it, it already has how many properties? It already has 5, even though that we haven't added anything. And the reason I'm saying that is because these are always parallelograms first, and then a rectangle, or then a rhombus, etc. Okay? I probably would like you to write that out there. Because when we get to proofs, the first thing you have to prove is that they're parallelograms, and then go on to prove a further down the road shape. These are p grams, and then I'm going to emphasize this word first. If we don't prove that they're a parallelogram, then we can't prove that there's something else beyond that. So, what do you think is true about a rectangle? I'll give you a hint. We're going to add 2 properties to a rectangle. What do you think they are? Corbin.
Like there's 2 legs that are longer than the 2 other ones.
Okay. Which is still, that's basically true of a parallelogram, right? We have 2 pairs of opposite congruent sides.
Yeah, but wouldn't that be
Yeah. Okay, so that's marked in the figure already. All angles are 90. And then the other property, it has to do with the diagonals. So what do you think is true about them? We already know something about them right up here. We know they bisect each other because it is a parallelogram first. But what else is true about these? Yeah, these ones are congruent. So we didn't add too much, but that's important stuff. Okay? It is important to recognize that the diagonals are congruent and bisected now, and that all the angles are 90. So another, I guess another piece of advice, or just a caution here, is to keep an eye out for what? If we have these 90s floating around, what might come up? We wrote this somewhere else on here. No, never mind. We wrote it I wrote it a similar way, but for a different reason. Keep an eye out for right triangles, right? For Pythagorean theorem. I hate it that it doesn't stay on the screen. What's the Pythagorean thing?
A squared plus b squared equals c squared.
So it could come up since we have 90-degree angles, just like it did in kites. And if you look just to the right, you'll see that it will probably come up in rhombuses too. Should we say rhombi? That just sounds weird, huh? Okay, rhombus. Also a few properties. What do you think that one has?
The like lines going through it are perpendicular.
What are those lines called?
Diagonals.
Yep. Diagonals are perpendicular. They also bisect each other. Do they look to be congruent? No. Remember to draw like a super extreme case? So does that one look the same length as that one? No. If you ever get stuck, just draw, like really emphasize some traits about it. So the diagonals are not congruent, but they are perpendicular. And of course, because it's a parallelogram, they bisect each other as well. All right, this is not in the figure, but what do you think is true about their side lengths? So like the heavier black lines. Yeah, they're all congruent. That should go in your picture. So all sides are congruent. And then we have one more. This one is subtle. So it's another diagonal property. So I'll just tell you that the diagonals are angle bisectors. So go ahead and put that in there. Just mark the angles congruent. I think I'm going to do a different color for that. Now, more properties are nice, but also means that we can solve more things. So now we could maybe solve for some kind of angle setup, obviously side lengths, right triangles for side lengths. The fact that the diagonals bisect each other, we could solve for that. What else? Maybe prove triangle congruence. I don't know. There's a lot in here, right? Okay. Now you see these two arrows pointing to a square. What does that mean? Yeah. So squares all of the above. Now let me clarify that. This is the easiest way to write it, but there is somewhat of a discrepancy, but I think it's okay. In other words, like rectangles don't have perpendicular diagonals. So we're not like trying to fight between these two. We're just saying take everything that's true of both and combine it into a square. So how many is that for a square? That's 10 properties for a square, for a simple little square. Cool, right? You never knew that a square was so powerful. How many of you could recreate everything except for what we wrote today on a blank one without notes? You should get to that point, okay? So study the heck out of this thing. Some of the pictures are helpful, but not necessarily for everything. Because remember, we added a lot of notation to these. Or some, maybe I should say some. Which one do you think is the hardest to prove? If I just said, here's 4 points, they make some kind of quadrilateral, prove which one of these it is. That's how your proofs will look at the end. 4 coordinate pairs, I'll say A, B, C, D. Here's the points, graph them, prove which of the quadrilaterals it is. Rhombus. Square is actually the hardest because you have to get all the way from the top down there. Okay? And that's why it's, if I want to prove a square, think through what you'd have to do. You don't have to do all 5 of these, you just pick one of them. So let's say both pairs of opposite sides are congruent. Let's say I pick that one. How do you prove opposite sides are the same length? What tool do you use? Distance formula. If I say both pairs, how many distance formulas is that? 4. Because pairs, right? 2 pairs, that's 4. So 4 distance formulas. That gets us to parallelogram. How do we get from parallelogram all the way to square? Well, we have to bring in a property from both of these, right? Does everybody see that? So diagonals are congruent. That would be 2 more distance formulas. Or you could do angles are 90. That would be a slope because we can show perpendicular by slope. We could do slope on the diagonals. We could show, we already did side length calculations up here. So if they happen to all be the same length, then we're already at here at number 2. So that would be nice. Okay? We can't show things like angles being bisected with either distance or slope. We can't do that. But we can show lengths. We can show 90 degree angles with slope. So it's usually, to get from top to bottom, it's usually at least 6 calculations, depending on if you're observing and making the best choices. It could be more. Do you see why? Yes. Okay. All right, we're going to run through just some checks on this to see if you can identify a shape based on notation and markings. But some of these are kind of easy. There it is. There is one. I mean, no, that's not it. Good grief. Here's one. Let's try this one. Let's just set it up. It tells you it's a rhombus. So that's huge. That tells you how many properties. Just in that one word, how many properties do we know are true about this figure? 8. 8 different things, right? So you see why it's important to know them so you know which ones to use. Is this angles? Is this side lengths? That's where I would start. Once you identify that, I would say, is this side lengths or diagonals? Okay? Which one do you think it is? We're asked about side lengths, but how do we solve? Well, we have 3 different x expressions. Do we just set them all equal? Do we write it like equals 180? What do you think? Let's say which 2 we're going to use. I'll tell you that. We're only going to use 2 at first. 2x plus 3. And what are we going to do with them? Y. Okay. Solve that in your head. What is x? 5. Good. Okay. Now we know x is 5. GH. What do we do? Just plug it in. Okay, so sometimes they try to bait you by putting more information than you need to solve for x, but then you have to use that extra information later. We've seen that before. This is not new. Questions on that one? Okay. All right, it says, what is the measure of angle MNO? It gives you angle MOL. MNO is this angle right here. What property are we using? It tells us it's a rhombus. That's 8 properties. Is this side lengths or angles? Okay, so that helps because it narrows it down to just angles, which is opposite angles are congruent. That's from being a parallelogram. Opposite angles are congruent. Consecutive angles add to 180. What else? What did we add just now for rhombuses? Yeah, diagonals are angle bisectors. That's a big one. And what other property did we add for a rhombus? Diagonals are perpendicular. So I would go add that is 90 right there. And then what about the 62? What can you do with it? Right there, because that's an angle bisector, those two are congruent. So now we're looking at this triangle with a 90, a 62, and our unknown. So how do we solve for that? Yep. Okay. You can see how at this point in the course, you kind of need to see some of those prior relationships pretty much right away, right? Kind of automatically. Is that happening for you? Cool. All right, a little bit of a busy figure. I'm going to give you just a second to work through this one. It says, what is QT? It's not a hard problem. You could probably do it in your head, but it's a little busy of a figure. So just take a second to read through that if you need to. Raise your hand if you have QT. Good job, good job, good job. Raise your hand up. Okay. Side lengths are angles. Yeah, maybe I should say lengths or angles because sometimes it's a diagonal. All right, what relationship are we using that's true about a rhombus? Say it, Braden. What property are we using? Side lengths are congruent. Good. So we set those two equal. And that tells us y is 4. And then we take that back in and we get 16. Okay? All right, let's do something else. Hey, there's a proof. You guys like horses? What do you like? All right, so he's training his horse to run at a pace of 4 meters per second or faster. Paul rides his horse from D to C to E to B in 1 minute and 30 seconds. Did he make his goal? What shape is it? Okay. What's true about rectangles? So you're going to listen carefully. I'm going to pick how many properties. Let's start with that. Does a rectangle have? 7. I'm going to pick 7 different people. And you better listen to what other people have said because you're going to give me a property of a rectangle. Everybody clear on what I'm asking? Okay? Good job. Property 1. It doesn't have to be the first, but just give us one.
All angles are 90.
All angles are 90, not in a rectangle.
Oh, parallel square. Square. Square bottom.
So what's another property? We have 7. We'll come back to you. Jesse, give me another one. Okay, so we could mark that. Diagonals are congruent. It's hard to mark the whole diagonal being congruent because you have that break in the middle. So I'm just going to highlight them and say they are. Okay, Lyra, give us another one. We've had 2.
The diagonals from rectangles.
That's not one of the specific properties of a rectangle. Isla, give us another. We'll come back to you, Lyra. Well, I'm not sure. Is this a square? Then why are we talking about a square? You can't read your freaking paper? Like, we have 7 properties for a rectangle, right? Like, where are you guys today? We're all tired, right? We all suck it up and keep going. Go back here. Five plus 2 is 7. We've been told that all angles are 90, and we've been told what did you say, Jesse?
All diagonals are.
Did you say that?
Yeah.
Okay. Read some of the other ones, right? Like, it's just being present, that's all. It's really not that hard. Give us another one.
Consecutive angles are supplementary.
Okay, are we going to use that in this one? Consecutive angles being supplementary, do we care about that? No, this is not an angle problem, but it's a property, and that's all I'm asking for now. Give us another one.
That's it.
Yeah, could that be a good one? Potentially, we might want to know if the diagonals are split in half. That could possibly be. Lyra, give us another one.
The diagonals are congruent.
Diagonals are congruent. I think we said that one. Do you have another one?
Opposite sides are parallel.
Opposite sides are parallel. Good. That's a side length property that is kind of confusing. Not confusing. It's a little misleading because it's about a length, but it's not actually telling us lengths, right? But that is a property of rectangles because it's a parallelogram. All right, Tim, what else?
Said it was a parallelogram. Is that not a? Is that not a? Is that not a property?
That encompasses 5 properties, so we're reviewing the individual ones.
Why not? Is that like AB's?
AB is what? Yeah, so what do we call that? Opposite sides are congruent. So we can copy 192 here and 80 here. Okay. Isla, are there any more? We haven't said one of them. It won't help us in this problem, but it's important to review. Opposite angles are what? Are congruent, right? Don't tell me. Which one do you think it is?
Have we said the consecutive angles or something?
Yeah, we said that one. Yep. All right. Now we have 7 properties listed. This person is going D to C to B. I skipped E. D to C. Let me highlight our path. D to C to E to B. And it took 1.5 minutes. So, do you guys know how to find the rate? It says he wants to run at 4 meters per second or faster. Do you know how to do that? It's kind of says it in the name, meters per second. So what would we do? divided by the time. It's literally all, right? Meters divided by seconds. How many seconds did it take him?
90.
Okay. So figure out the meters and divide it by 90 and let me know. We'll pause there. How far did he go on that little pink pathway? All right, here's the plan. I'm going to zoom in on this left half of the rectangle. So we need to know this, x, I'm just going to call it, so that we can split it in half. And this is a right triangle, so 80 squared plus 192 squared, square rooted. That's going to give us c, or in this case I called it x. So Pythagorean theorem, a squared plus b squared equals c squared. We don't want c squared, we want c, so we'll square root this, and we'll go square root of 80 squared plus 192 squared gives us 208.4. And what's the unit on that? This is a story, so we need a label. That's meters. Okay, that is the whole length of AC. So I'm going to chain a couple equalses together. So AC is 208.4. We want EC. So what is EC? Yeah, it's half, right? Because this is a parallelogram first, so that means its diagonals are bisected. So EC is 104.2 meters. Okay, and then we need EB or BE. What's true about a rectangle specifically? In terms of diagonals, what else is true about them? The diagonals are congruent, so isn't BE also... let's call it EB just to be consistent. Isn't it also 104.2? Yeah, because the diagonals are the same length, so taking half of the other diagonal is going to be the same. So his total distance, we just add those three pieces. So 192 plus 208.4. I'm just doubling the two halves there. And we're going to divide that by the total time, which was 90 seconds. And you're doing it, right? What'd you get? 4.4 meters per second. And he wanted to be 4 or faster, so did he make it? In other words, is it better to be above 4 or below 4? Above, right? Because if he was going 20 meters per second, that's way faster than 4 meters per second. So he met this, right? Yes, he did. All right, there's a good in context kind of rectangle. All right. There's a square. Sometimes squares are tricky. It says find the measure of YPZ. That angle right there is what?
Wait, what did Z and Y
What's the measure of this angle? We're starting with that. That's 90, right? Because it takes on that property of a rhombus, so those diagonals are perpendicular. All right, angle XWP. That's this one. This is kind of like an equilateral triangle. Those angles will always be this measure. What is it? Property of a rectangle, property of a rhombus combining to make this possible.
Wait, just to clarify, is N Earth PZY 7?
PZY sounds like an angle. The 7 is just side length or diagonal length, ZP.
Well, I couldn't tell if the 7 was for that angle or if it was for the side line.
I see. Yeah, that's a side length. So it's going to be used on the last question. Okay. XWP, anybody get there? It's always true for every time you have the diagonals drawn into a square, each of the 8 little angles are always going to be what? 45. They're always bisecting a 90. So it's 45 degrees. All right. XZ. That one's easy. What's XZ? Just double 7. That was kind of a dumb problem. All right. What kind of shape is that? We had a problem almost just like this last unit that was two, just like this, isosceles triangles. But what is this one? It's a rhombus. So what's true about angles in a rhombus? Well, I want to. Yeah. Diagonals are perpendicular. Is this a diagonals problem? What kind of problem is this? This is angles. So what's true about their angles? Yep. I'm going to pause here and let you work this one. See if you can put these properties together to solve it. It just says solve for x, so you don't have to plug it back in. What is it first? Parallelogram first, right?
Yes.
How do we know that?
Because it says it on the paper.
No, it doesn't. It says what is the value of x?
No. Oh, wait. Because
How do we know it's a rhombus?
opposite sides of both sides of
It's because all sides are congruent. Is that true of any other figure but a square? Nope. Look at them. None of the rest of the quadrilaterals have all sides congruent besides a square. But is this a square? No, because why? But that's not why. It's not a square.
There's no 90 degree.
Yeah, we have no information that says it's got 90-degree angles, right? So we can't say it's a square. In other words, if we are like going down the pathway, as far as we can get is a rhombus. Am I going to read proofs on the test that say it's because it looks like a square? I do think students do that because I'll show you problems like that here in a second, but basically it's a figure with markings and you have to tell me the most specific classification that you can. And then also we do proofs, but these are like mini proofs. We had those last test. And sometimes I think students just write what it looks like. Yeah. Anybody there yet on this one? Guys like geometry? For most people, Algebra 2 is quite a bit harder than geometry. I'm only telling you that so you develop good study habits this semester. Okay, let's check this. I'm going to ask this question first because if you don't know, you can't proceed, right? So why did we decide it was a rhombus? So all sides are congruent, but no 90s. Okay. With that said, what can we do to solve for x? Are those two angles equal to each other? No, not necessarily. So what else can we do? Can we copy that right there? Why? Okay. All right. And then what is true about that whole angle and that whole angle in a parallelogram? Yeah. So we can say plus 8x minus 6, and then that whole thing equals 180. And then from there, we're just solving. So 8 and 8 makes 16, 5 and negative 6 makes 4. And that's 16x, not 16. Okay, 16x equals 176. Did anybody do that division? Thanks. Cool. All right, maybe we'll come back to some of these. This is the kind that I want you to, we're going to do. This is going to be rapid fire, okay? So I don't want you to shout it out. We're going to do a bunch of these little partial proof kind of problems, okay? You don't have to prove it. You just need to decide. It says, can you conclude whether the parallelogram is a rhombus, a square, or a rectangle? In other words, is there enough information to decide fully on one of those? Keeping in mind, it did tell us that it's a parallelogram, which means all 5 of those properties for sure are there. And then we add a little bit more information. Okay? So raise your hand when you know, when you have your vote, I mean. And please don't base it just on what it looks like. You've got to be able to justify. All right, that's most of you. What do you guys think? A rhombus? Okay, now justify. Why? You are correct, by the way. Yeah, this is stupid because sometimes this book does this. What this really means is that the two angles, the angle is bisected. But it doesn't show it that way. It's kind of dumb. It just looks like one line. Do you see what I mean? But it does mean that that angle is bisected. That's a property of a rhombus. Plus, since it told you that this is a parallelogram, we can take this tick mark over here. That's a property of a parallelogram. And this tick mark over here. And now what else is true? Yeah, all sides are congruent. But it's not a square. We can't go that far because yeah, perfect. All right, you guys get the idea. So that's a rhombus. Let's try another one. Okay, again, it's a parallelogram. Is it a rectangle, rhombus, or square? See if you can put together an argument as to why you think it is what it is. Kind of like what we just did. Everybody ready to vote? Okay, what is it? Okay. Zeke, why?
Because the diagonals are congruent to each other, and also it has 90 degrees on the diagonals as well. All the diagonals are 90.
Okay, so check it out. We were told it's a parallelogram. Diagonals being congruent means it's a what? Just think about walking down your flow chart that we wrote. We're down to parallelogram because it was given. Diagonals being congruent means we're at a rectangle. And then what does that do? The 90. Yeah, that brings in a property of a rhombus. So if it's a rectangle and a rhombus, it's called a square. Yeah, that's the argument that we're trying to put together there. All right, let's do another one. is the parallelogram. Again, we're told that. You're not going to be told that on your proofs. So is it a rectangle, rhombus, or square? Now, we know what it looks like, but can we conclude for sure that it's that? Okay, which one is it? Why?
Because there's 90 furthest of the bisects.
Okay, we can copy this there. Why? Why? Because it's a parallelogram. We can copy this there for the same reason. And then all four of those tick marks tell us that what is true? The diagonals are congruent. That is only true of a rectangle or square. But it's clearly not a square. So this is a rectangle. Are you getting the hang of it? Melissa, this is all yours.
I need to use the bathroom.
It is a parallelogram. Yeah, think about your argument, not just what it is. Does everybody agree it's a rhombus? Do we know why? That's only true if it's a rhombus. We have to prove that it's a rhombus using something that we already know. Does that make sense? No right angles, that's good. What else? Okay, but that's only if it's a rhombus. Can we argue that that can be copied over there? Why? You can't say because it's a rhombus, because we don't know that yet. Okay. I don't know if you heard Tim, but he's saying, can we use same side interior angles to bring this over here because it's a what? Parallelogram first. And he's right. Now this shows that the angles are bisected, which makes it a rhombus. You see, we have to be careful not to use what we're trying to prove itself. Yeah.
Is there ever a time that it will look like a rhombus but it's actually a square? Or it'll look like a square but it's actually a rhombus?
It could, on these kind, it could get close to that. If it's what we call a coordinate proof, where you're plotting points on graph paper, then no. I mean, unless it's so close that you can't really tell. You know what I mean?
Yeah.
Okay. All right. Let's pause there. I'm going to get you started on something. I want you to think of this as building your logic and reasoning for proofs, for these kind of proofs. Not the worksheet, I'm talking about what we just did.
I hope we stop making those stuff.
No. Oh wait, no, it's 35. I was thinking 20. Can you wait till I tell you what to do? All right, everybody listen up. We're not going to do this whole sheet. So let me tell you which ones I want you to do first. Okay. Do 1 through 8. And then flip it over. On the back, do 1 through 6. Those will be due in the morning, and then we'll probably finish the rest of it in class tomorrow. No, don't exit out. Yeah. We'll probably finish the rest tomorrow. So 1 through 8, 1 through 6 on the back, and We do still have about 15 minutes. You might be able to get a lot of it done before
Okay,
this.
6 on the debate? Yeah.